First,
Okay, good evening. Audible, na? My voice? Yes. Yes, yes. Thank you, thank you. Thank you. So, last day, we discussed some basics. What is a pole? What is a zero? What is a characteristic equation? So, some basic points we discussed it. And time constant. We solved the problems, even type and order. Type of the open loop system, type of the closed loop system. So, today we'll continue that. Okay. Okay. Listen here. Okay. Right. See, one of the most important point is, listen all of you. I think some students are even not studied control system in the BTech. Who are not studied, just first time they are listening the control system. Then you should listen carefully, and then for 1 hour class you have to work at least 2 hours. Then you can become the perfect. Another thing, once if you understand here, you'll get the very good marks in the university exam also. It is very, very much useful for university exam. Okay. So that's why listen carefully. If you have any doubt, you can ask to me. Okay. Next. See, while finding system response, listen, while finding approximate system response, system stability, system time constant, while finding approximate system response, system stability, system time constant, consider only poles. Considered only poles. We considered only poles while finding system response, system stability, system time constant. Consider only poles. We consider only poles. Okay. Why we consider only poles? Why not zeros? So anybody answer? Why we consider only poles? Why not zeros? Anybody? Why we consider only poles? Anybody answer? Okay. Listen here. For example, I'll take 1 minute. I'll reduce the fan speed. 1 minute. Right? Right. Why we consider only poles? Why not zeros? Listen. I'll take one simple example so that you can understand. See, for example, C of S by R of S equal to S plus 1 divided by S plus 2 into S plus 3. It is a simple transfer function. So now, why we are considering only poles? Why not zeros? For stability also we'll observe only poles. If somebody asks either system is stable or not, mean just we'll observe only poles. For system time constant also we consider only poles. Even exact response means you have to consider poles as well as zeros. But approximate system response means we consider only poles. So for objective type, they used to ask system response approximate. So that means by looking at pole itself, we can identify the response of the system. So for first, we'll find the system response. I already told system response is nothing but what? Impulse response. System response, another word is what? Impulse response. Impulse response. Impulse response. That means R of t equal to del of t, R of s equal to 1. Laplace of impulse is 1. So R of s equal to 1. Now we substitute here R of s is 1. Then C of s becomes s plus 1 by s plus 2, s plus 3. Partial fractions you find out. Find the partial fractions. What I will get? S plus 2 equal to 0. S equal to minus 2. Minus 2 if I substitute here minus 2, here minus 2, here become plus 1. Numerator minus 1. Yes or no? So that means minus 1 by s plus 2. Then again s plus 3 substitute. S equal to minus 3. Minus 3 plus means here minus 2. Here minus 1. That means plus 2. Plus 2 by s plus 3. So then find the inverse Laplace transform. You find C of t. C of t equal to what you are getting? Minus 1 e power minus 2t plus 2 e power minus 3t. Default you can write u of t. Default you can write u of t. See, this is a what? System response. See, if you observe the system response, what it consists tell? E power minus 2t, minus 2. For example, to the transfer function, I'll represent the poles and zeros. I'll represent the poles and zeros. What are the poles and zeros? So this is 0. So pole location 0 is minus 1. One pole is minus 2. One pole is minus 3. One pole is minus 3. Now see, observe, we got e power minus 2t. E power minus 2t because the pole at minus 2. We got e power minus 2t because the pole at minus 2. E power minus 3t we got because the pole at minus 3. Because the pole at minus 3. So that means we got a term for this pole. We got a term for this pole. Where is the term for 0? Where is the term? There should be a term like e power minus 1 into t na. Where is the term for 0? Tell. There is no 0 terms exist in the system response. There is no 0 terms exist. There is no 0 terms exist in the system response. System response always consists only poles. System response minus 2 is a pole. Exponential powers are nothing but real part of the pole. Exponential power is nothing but real part of the pole. Minus 2 is a pole, minus 3 is a pole. So system response consists only poles locations. System response always consists only poles locations. Be remember. System response consists always poles locations only. Only poles like that's why while finding approximate system response, if you ask, for example, if you given this transfer function, if you ask system response, I don't do all this thing. Pole at minus 2. So minus 2 means e power minus 2t. I don't want this constant. E power minus 2t exponential decay. E power minus 3t exponential decay. Simply I'll say answer is exponential decay. Simply I can say the approximate system response is exponential decay. So whenever they ask objective bits especially, they'll give the only approximate response. Objective bits especially, they'll give only approximate response. For that, you see the exponential term and write the answer. E power minus 2t exponential decay. E power minus 3t exponential. The answer is exponential decay. That's all. No need to solve. No need to find partial fractions. No need to find CFT. If you ask exact response, then no doubt you have to zeros also having effect on exact response, because that constant of where it starts also important. But just like a match the following questions, sometimes they'll ask. There they'll give only approximate response. There they'll ask only approximate response. In that case, you directly look the pole location, tell the answer. Okay, it will come next after some time. I'll take the different location of the poles. I'll draw the responses. Okay, na? So what is the conclusion here? For system response, consider only poles, because system response consists the only poles locations. System response consists only poles response terms. Only poles response terms. No zero term. No zero response term. No zero response term exist in the system response. 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 That's why we consider only poles while finding the approximate system response. Next, system stability. So for system stability also consider only poles. For system stability also consider only poles. How to find system stability? First of all, tell. For system stability, what you have to do? How to get system stability? Anybody? For system stability, what you have to do? Substitute t tends to infinity in the system response. Substitute t tends to infinity in the system response. In the system response. Substitute t tends to infinity in the system response. If you substitute, for example, you substitute here t tends to infinity, e power minus infinity 0, e power minus infinity 0. 0 means finite or infinite? Finite value. If in case you are getting finite value, then that system is a what? Stable system. That system is a stable. In case you are getting infinite infinite value, then that system is what? Unstable. That system is unstable. So now substitute t tends to infinity at 0. That means stable. Another thing, why we consider only poles? Because here consists the what? Only poles term, minus 2, e power minus 2t pole term, e power minus 3t pole term. Even if we change this 0 position, for example, I'll put here minus 1, then is anything change here? This constant will change. 2 minus 1 may change, but there is no change in the what? E power minus 2t. There is no change in the what? E power minus 3t. That means what? The stability is not going to be changed. Whatever the constant here, k into, for example, k1 into e power minus 2t, for example. E power minus infinity 0. 0 into any value, whatever the value, it will become 0. That's why system stability depends on only poles. For example, pole location change, stability changes. For example, if I put here minus, what happened? Tell. Here it will become what? Here minus 2. That means e power plus 2t. Here it will become plus. E power plus infinity becomes what? Infinity. System become unstable. E power plus infinity become infinity. That means infinite value. System become unstable. That means what you understood? The pole affect the system stability. The 0 is not affecting the system stability. Poles always affect the system stability. Zeros are not affecting the system stability. That's why for system stability also consider poles. Simple way, why consider only poles for system stability means we can say that the system response consists only poles term. That's why consider only poles for system stability. Okay, na? Next, time constant. Here minus I'll take. Okay. Next, system time constant. So why we need system time constant? Tell. System time constant mainly required to draw the response. System time constant mainly required to draw the response. So system time constant. System time constant mainly required to draw the response. To draw the response. Last day we drawn the response na 5 tau. The response by using a tau we drawn the response na. So system time constant mainly required to draw the response. When you want to get the time constant from the response, what you have to do? You have to compare the response with what? Compare response with, to get time constant, what you have to do? Compare response. Compare response with, bolo, e power minus t by tau. You should compare the response with e power minus t by tau. If you want time constant, we require to compare the response with e power minus t by tau. For example, compare here e power minus t by tau. Compare with e power minus t by tau. Come on, compare with e power minus t by tau. You compare with e power minus t by tau. What happened? 1 by tau equal to 2. That means tau equal to 0.5. 1 by tau equal to 3. Tau equal to 0.33. That means we got time constant for this pole. That is 0.5. We got time constant for this pole. That is 0.33. Yes or no? We got the time constant for the first pole. That is 0.5. Second pole is 0.33. 1 by tau now. 1 by tau equal to 3. 1 by tau equal to what happened? 3. 3 means 1 by tau equal to 1 by 3. 0.33. 1 by tau equal to 2. Tau equal to 0.5. That means we got time constant for this pole. We got time constant for minus 3 also. We got time constant for minus 2 as well as minus 3. But we didn't get the time constant for what? 0. We didn't get any time constant for this 0, na? So did you get time constant of 1 second? No. That means what? System time constant means pole's time constant only, but not the zero's time constant. System time constant means pole time constant only, but not the zero time constant. That's why for system time constant, consider only poles, because the reason is system response consists only poles location. The main reason is this only. System response only consists poles. That's why for system stability, for system time constant, we consider only poles. So be remember this. So while finding system response, system stability, system time constant, consider only poles. While finding system, you can say approximate. Why? Exact means you have to consider poles and zeros. While finding approximate system response, and system response, system stability, and system time constant, consider only poles. Consider only poles because the system response consists only poles response terms. No zero response term, no zero response term exist in the system response. Okay, be remember this. Okay. Then the question here arises. Then why zeros are needed? If everything you are telling pole, then why zeros are needed? Listen here. Listen. Importance of the zero. Listen. Listen. See, if I take a open loop system, listen carefully. Then only you will understand. If I take a open loop system, it defined as what? Open loop transfer function of a system. Already I told. So open loop transfer function of a system. That is what? G of S. G of S equal to what? K into some open loop zeros by open loop poles. Open loop zeros by open loop poles. And instead of writing K into 1 plus S tau 1, 1 plus S tau 2, and so on, divided by S power n into 1 plus S tau 1. Instead of writing that, just I written open loop zeros by open loop poles. Now I can tell here, we can clearly tell that open loop poles, open loop zeros, especially open loop zeros, never affect the open loop stability. Open loop zeros never affect the open loop stability. Open loop zeros never affect the open loop stability, and even time constant, even response also never affect. But if I go for closed loop system, closed loop system defined as what? Standard form of closed loop system definition. What is the standard form of closed loop system? Closed loop system not defined directly closed loop transfer function. Closed loop systems are not defined directly in terms of closed loop transfer function. It defined in terms of what? Open loop transfer function. What is that? Open loop transfer function of a unity feedback system. open loop transfer function of a unity feedback system. That is what G of S equal to what I can write, K into open loop zeros divided by open loop poles, K into open loop zeros by open loop poles, where H of S what? 1. So unity feedback na very clearly mentioned, unity feedback means H. So this is a standard representation. Now, is this the final function? Is this the final function? It is not a final function. So because feedback, what happened? Due to feedback, it will become closed loop. Then we have to find the closed loop transfer function. So that closed loop poles will affect the system stability. So now find closed loop transfer function. What is the closed loop transfer function? C of S by R of S equal to G of S by 1 plus G of S. 1 plus G of S. That means what you are getting, tell? K into, simply what I told, open loop zeros by open loop poles plus numerator term added in the denominator. Simply how to get closed loop transfer function? Last day I told, to get closed loop transfer function from open loop, add the numerator term in the denominator, simply K into open loop zeros. Open loop zeros. This is the closed loop transfer function. Now tell what happened here. So this denominator term gives the closed loop poles. This denominator term gives the closed loop poles. So that means what are the closed loop poles? Tell. It is sum of open loop poles plus open loop zeros with the function of what? System gain K. That means closed loop poles are nothing but open loop poles and open loop zeros with the function of system gain K. That means open loop 0 will affect the closed loop stability. Open loop 0 will affect the closed loop stability. Open loop 0 never affect open loop stability, but open loop 0 will affect closed loop stability. If the system is closed loop, open loop 0 will affect the closed loop system stability. So what is the conclusion here? I'll write in the next page. What is the conclusion? Open loop 0. Open loop 0 affects the closed loop system stability. Closed loop system stability. Poles automatically affect, but open loop 0 will affect the closed loop system stability because what is the reason? Because closed loop poles are nothing but sum of open loop poles and open loop zeros with the function of K. With the function of K. That's why closed loop 0, closed loop, there is no word of closed loop 0. Closed loop 0 equal to open loop 0 only. But open loop 0 will affect the what? Closed loop system stability. So closed loop system stability depends on what? Open loop poles as well as open loop zeros. Whereas open loop system stability depends on only open loop poles. Open loop system stability depends on only open loop poles. Closed loop system stability depends on open loop poles as well as open loop zeros. Okay, na? So be remember this. This is very, very important. Okay. So that also with the function of system gain K. So these are the basics. Next, we'll go for the transfer function to the electrical network. Next topic, transfer function to the electrical network. Transfer function to the electrical network. So take a simple transfer function. For example, I'll take a simple transfer function. Z1 of S Z2 of S B naught of S A of S. If any electrical network is given, then you adjust the components in this form. If any electrical network is given, you adjust the components in this form, Z1 of S and Z2 of S. Once you adjust in the adjusting means what? Simplification of series parallel components. For example, see, I'll take here one resistor in case parallel some inductor is there. Then simplify this. Then that you take it as a what? Z1 of S. Simplify this parallel combination. That you take it as a Z1 of S. Okay, na? So now once you get this, the transfer function V naught of S by VA of S equal to impedance across output to total circuit impedance. Impedance across output to divided by total circuit impedance across output to total circuit impedance. Total circuit impedance. Impedance across output to total circuit impedance. What is impedance across output? Z2 of S by Z1 of S plus Z2 of S. Z1 of S plus Z2 of S. That's all. Okay. Next. Got it, na? Next one. Note on the problem. One simple problem in order. Right. Next. Next problem. Find the transfer function. Find the transfer function to the given electrical network. Find the transfer function. Find the transfer function to the given electrical network. B bit. Okay, set and locate poles in the S plane. And locate poles in the S plane. The first bit. Second bit. Find system response. Come on, simple electrical network I'll give. I think we already solved it. Still one more time solve. Come on, do it. Find the transfer function, come on. Come on, find the transfer function. What is the answer? Anybody? One by SCR. 1 by 1 plus SCR. Good. 1 by 1 plus SCR. Correct. Listen. Say apply first Laplace transform. Laplace of resistor is R only. Laplace of capacitor 1 by SC. So output V naught of S. Input VA of S. Now find the transfer function. Find the transfer function. Solution I'll write here. Find the transfer function. So V naught of S by VA of S equal to impedance across output 1 by SC by total circuit impedance R plus 1 by SC. 1 by SC by R plus 1 by SC. So then what you are getting? 1 by SCR plus 1. Tau equal to what? RC. Tau equal to RC. That means what is the transfer function? Tell 1 by S tau plus 1. 1 by S tau plus 1. This is the transfer function. So now locate the poles in the S plane. Locate the pole in the S plane. Where is the, what is the location of pole? Tell S equal to what? Minus 1 by tau. Pole location is, so S equal to minus 1 by tau. S equal to minus 1 by tau. Pole location is minus 1 by tau. S equal to minus 1 by tau. Now find the system response. Find the system response. System response. Find system response. System response. System response means impulse response. That means R of S equal to 1. Sorry, VA of S equal to 1. VA of S equal to 1. You should solve. So VA of S equal to 1. Then what happened? V naught of S equal to 1 by S tau plus 1. Then tau take it common. 1 by tau take it common. S plus 1 by tau. S plus 1 by tau. Apply inverse Laplace transform. Then V naught of T equal to 1 by tau e power minus T by tau. Default U of T. Now draw the response. So draw the response. So what is the response? Tell exponential decay. So this is T. This is V naught of T. V naught of T. T equal to 0. Where it starts? 1 by tau. T0 e power 0 1 na, so 1 by tau it starts. Then T equal to infinity, for example. That means what happened? E power minus infinity becomes 0. So that means exponentially decays to 0 like this. Put the dots. That means that will move up to infinity. So it reaches almost steady state at 5 tau. What is the nature? Exponential decay. System what happens? Stable, 100% stable, because substitute T tends to infinity here. E power minus infinity 0. That means the system is stable. S means stable. The system is stable. So that means what happened? What you understood here? What you understood? The simple RC network. The simple RC network given a one pole on the negative real axis. The simple RC network given a this RC network. The simple RC network given a one pole on the negative real axis, and it given a response of what? Exponential decay. The simple RC network given a one pole on the negative real axis, and it given a nature of exponential decay. Exponential decay. In case I'll represent many poles on the negative real axis, what happened? Anybody? In case many poles represented on the negative real axis, what happened? At different locations, you'll get approximately exponential decay only. Approximate nature is exponential decay only. Or the one more thing also, even some students, they given the question and answers. So pole decide the characteristics 100%. System pole gives the what system characters. That's why characteristic equation definition is what? Denominator of the transfer function. But how can you change this pole location? Anybody? Or what are the possibility of changing the pole location? I want to change a pole location. How can you change the pole location? What are the possibility of changing the pole location? Anybody? How can you change the pole location? Anybody? By changing? By changing the tau, correct. Changing. Pole location changed by changing the component values. Component values, if I change, for example, R and C value, then what happens? Generally, C we don't change. I'll change just R value. As R is go on changes, what happens? Tau change. Tau changes means pole location changes. But here thing is that the tau is always positive because R is positive, C is positive. Component values always positive only, na? So RC positive, that means tau positive. As long as tau is positive, the pole always lies in the left hand side only. There is no chance of moving a pole to the what? Right side with tau. There is no chance. It cannot place the pole in the right side with respect to tau. That's why you want to place a pole at desired location, that also without changing the component value. I want to place a pole at my desired location without changing the component value. That means main system should not disturbed. Main system should not disturb, but pole location should be changed. How it is possible means this system you have to put in a what? We have to put in a closed loop configuration. We have to put in a, for example, I'll draw a block diagram for the variable pole moment. For variable pole moment, I'll draw a block diagram. See, for example, listen here. Variation of pole location. Variation of pole location with respect to, okay, variation of with respect to K. With respect to K. So for to get this, what you have to do? You have to take a unity feedback system. Here we have to connect a K system gain. Here K we have to connect. How to obtain K? K means what? System gain. How to obtain system gain? Gain of the system obtained by amplifiers. I'll draw the diagram for this. So here in this block, RC component. Here C of S. Here minus. Now tell, what is the transfer function? Tell here. What is the transfer function of this RC network? 1 by S tau plus 1. 1 by S tau plus 1. 1 by S tau plus 1. Now, what is the transfer function? This 1 by S tau plus 1 series with what? K. That means what you are getting in the forward path? G of S becomes what? K by S tau plus 1. Now you write a closed loop transfer function. C of S by R of S equal to G of S by 1 plus G of S na. So G of S by 1 plus, how we got G of S by 1 plus G of S? I'll discuss it. Some people this don't know. They didn't study in the BTech. Sorry, in the block diagram, I'll give the idea how you got this. So that also they are asking in the doubts. So that means some students they didn't study control systems. That is a problem. So brief idea I will give. So now K by bolo S tau plus 1. Simply add the numerator in the denominator plus K. That means what is the pole location? Tell. What is the pole location? Find the pole location. S equal to what? Tell. Minus of bolo 1 plus k by tau, minus of 1 plus k by tau. Now I don't change any value of tau. I'll change, what is the pole location? I don't change any value of tau. I'll change the just k value so that I can place the pole at any location. So that I can place a pole at any location. So what is the pole location? Minus of 1 plus k by tau. What is the range of k? K range is what? Generally minus infinity to plus infinity. So range of k is minus infinity to plus infinity. Now tell k0. What is the pole location? Minus 1 by tau. K is, for example, minus 1. K minus 1 means the pole come to origin. K in case minus 10, the pole come to the right. So wherever you want, you can place a pole by changing the k value. So that's why in the stability, they'll discuss the range of k value for stability. Why they are not discussing range of tau for stability? Tau is always positive, pole always lies in the left, system is always stable. But with k, we can place a pole either in the right or left or in imaginary, anywhere we can place it. That's why we used to discuss the range of k value for system stability is. So how can you change a pole location? Means simple answer is by changing the system parameters. System parameters are what? One is k, second one is tau. K and tau is system parameters. But which is more, means k is more important compared to tau. As k changes, we can place a pole at any location. Another advantage is, this is for example some motor. So this is a motor. This motor giving a pole location at minus 1 by tau. By adding a k, without changing any component value in the motor, by changing k, I can place a pole at any location. I can get my desired response. I can get the desired response. This is the advantage of putting the systems in a unity feedback configuration. Okay. So variable pole location, this is with respect to k. As k changes, pole location changes. As the pole location changes, the response is going to be changed. As k changes, pole locations are changes. Pole locations are changes. And system response changes. System response characteristics changes. Okay. Okay, this should be remember. Before that, what you have to remember? You remember this. One pole on the negative real axis. What is the system nature? Exponential decay. The pole on the negative real axis, system nature, exponential decay. Okay, next. For example, I'll take the many poles on the negative real axis, not one pole. What is the system response? You tell. I'll take one pole here, 1 pole here, 1 0 here, 1 pole here. What is the approximate system response? Find approximate system response. Come on. Find approximate system response. Find it. K is system gain. K is system gain, which is obtained by amplifier. Which is obtained by amplifier. Op-amp, amplifier. Non-inverting, inverting amplifier generally they will use. When you use single stage inverting amplifier, gain is negative. When you use multi-stage inverting amplifier, gain is positive. That's why I written K is minus infinity to plus infinity. Now find approximate system response. So what is the approximate system response? Sometimes in the exam, they'll give like this only. They don't give values also. They don't give the location of poles, location of zeros. They'll give like this. Then how to find system response? Simply left-hand side poles, exponential decay. It may be one pole or many pole. Blindly we can say the system response is exponential decay. For example, see. For example, I'll take this is -1, this is -2, this is -3, this is -4. -4. What is the response for this pole? I told already. What I told? The real part of the pole become an exponential power, na? That means what is the response for this pole? Some k1 into e power -1t. Some constant k, e power, the pole location into t. So exponential power is a pole location only. Exponential power. For example, see, exponential power is a pole location. For example, you see, e power -at, for example. So what is the Laplace of e power -at? Tell 1 by s plus a. You should know Laplace transform. You should be perfect in finding the Laplace transforms, partial fractions, simple integrations, and differentiation. These things you should know. Then you can able to understand the subject. You can able to solve the problems. Okay, na? So now, for example, 1 by s. What is the pole location? Tell here -a. So what is the -a here? E power -a. What is the -a? Exponential power. So exponential power is nothing but a pole location. Exponential power is nothing but a pole location. If you ask what is the response for this, I can take some constant k into e power -at. Like this I can write. What plus, what is the response for this pole? Tell some k2 into e power -2t. Some k2 into e power -2t. What is the response for the 0? Zeros not gives any response. Zeros terms not present in the response. Zeros terms are not present in the response. Zero terms are not present in the response. Okay. Next pole. So what happened? What is the response term for this? Tell some k3 into e power -4t. E power -4t. That means if I draw the response here, if I draw the response, this is t, 0 starts at k1 and exponential decay, reach the steady state at what? 5 tau. Tau equal to what? 1 second now. 1 by tau is 1. Tau equal to 1 second. That means reach steady state by 5 seconds. Plus, next start at where? T equal to 0. Where it starts? K2, 0 at infinity 5 by 2 at 2.5 seconds. It reached steady state by 2.5 seconds plus t equal to 0. Start at where? K3. Start at K3. T equal to 0. 5 by 4 and which in 1.25 seconds. Which in 1.25. Find the tau. This is 5 tau. This is 5 tau. 5 tau. 5 tau. Find the tau. Substitute the tau value. 5 tau value. So tau is 1 by 4. So 5 tau means 5 by 4, 1.25. So now, 1 minute. Right. Right. Now draw the response. Now draw the response. So sum of these three responses becomes the what? Exponential decay, exponential decay, exponential decay. Becomes exponential decay only, na? Becomes exponential decay. This is t. This is c of t. Here some constant k or k1 plus k2 plus k3. Then what happened? So it end at wait at what time? 5 tau, 5 seconds. It end at 5 seconds. 5 seconds only, na, which is decided by dominant pole, which is at what time it reached the steady state means that decided by dominant pole. That is what? 5 seconds. That means what is the approximate response? Tell exponential decay. Approximate response is exponential decay. System is what? Stable. That means if one pole or many poles placed on the negative real axis, this is very important. By looking a pole location, you should able to identify system response, system stability, system time constant. You should be able to identify system response, system stability, system time constant. So be remember. So left-hand side poles blindly should say exponential decay. Left-hand side poles approximate response, not exact, approximate response, approximate response. Exact means you have to find in what they don't ask exact. Most exact means directly they'll give the pole location. They'll give the pole location, then inverse Laplace transform we can use. We can find exact response. But generally in the objective type, they'll ask only approximate. They don't give pole locations at all. Okay, na? So approximate response is exponential decay. The system is stable. That means what is the conclusion? If one or many poles lies in the left of S-plane, if one or many poles lies in the left of S-plane on the real axis, at different locations, then system response is approximate system response is approximate system response is exponential decay. Irrespective of position of 0. Irrespective of position of 0. And the system is stable. So this is the first conclusion you should remember. It's very important. This is the first conclusion you should remember. If one or many poles lies on the negative real axis at different locations, blindly should say that the system response is exponential decay. One or many poles lies on the negative real axis at different locations in the left hand side. So blindly should say exponential decay and system is stable. Okay. Next problem. Got it, na? Any doubt? Right. Next problem. Repeat the above problem. Same thing. Find the transfer function. Either write it or question you write. Find the transfer function. Find the transfer function and locate the poles in the S-plane by considering R equal to 0 ohms, L equal to 1 Henry, C equal to 1 farad. B bit. Find system response. Find system response. Draw the circuit. Come on, solve it. Come on, do it. Exact response means with values will represent. That's all. At t equal to 0, what is the value you are getting? That will represent. That is called exact response. Approximate means we don't consider the value at t equal to 0. Just some value will take, we'll draw some constant. That is the only difference. What is the answer, anybody? Find the transfer function. One by 1 by s square, 1 by s square plus 1. Correct. Very good. Okay. Right. System response means impulse response. Impulse means VI of S is 1. Signals and system, I think, completed Laplace of impulse also. If you don't know, then problem na. Laplace of impulse, step, ramp, parabolic, simple Laplace transforms you should know. Mathematics, it will come in the mathematics, signals and systems. So now find the transfer function. What is the transfer function? V naught of S by VI of S equal to first apply Laplace transform. VI means VI of S. V naught means V naught of S. Laplace of capacitor 1 by SC. Laplace of inductor SL. Laplace of inductor XL SL. Okay. Now, next. What happened here? Find the transfer function 1 by SC by divided by R plus SL plus 1 by SC. 1 by SC. So now simplify this. Simplify this. 1 by S square LC plus SCR plus 1. Okay. Now substitute RLC values. You substitute R0. R0 means middle term 0. Then transfer function becomes V naught of S by VI of S equal to 1 by S square plus 1. 1 by S square plus 1. 1 by S square plus 1. Now locate the poles in the S plane. S equal to what? Plus or minus J1. S equal to plus or minus J1. Represent in the S plane. Zero. This is imaginary axis. This is real axis. Now tell what is the pole location? S equal to plus or minus J1. So one pole here. Plus J1 minus J1. Now tell what is the time constant, anybody? What is the time constant, anybody? Time constant definition. Minus 1 by real part of the pole location. What is the time constant, anybody? What is the time constant? S sin t. Right. Time constant is infinity. So this is what? So here what is tau? Tau equal to minus 1 by real part of pole 0. That means tau equal to time constant should not be negative. That's why infinity. Time constant should not be negative. So infinity. Real part of the pole always gives time constant. Imaginary part of the pole. What is the significance of imaginary part of the pole? Imaginary part of the pole gives the frequency of oscillation. Imaginary part of the pole gives the frequency of oscillation. Real part of the pole gives the time constant. So imaginary part of the pole gives the frequency of oscillations. Frequency of oscillations. Real part is time constant. Imaginary part frequency. What is the frequency of oscillation? 1 radian. It is omega n actually. It is omega n. That means omega n equal to 1 radian per second. 1 radian per second. So real part gives the time constant, imaginary part gives the frequency of oscillation. One more thing, be remember, non-repeated poles on imaginary axis system is marginal stable. Non-repeated poles, non-repeated poles on j omega ante imaginary axis. Imaginary non-repeated poles on imaginary axis. So makes the system marginal stable. Non-repeated pole on j omega axis makes the system marginal stable. Because how the response of marginal stable? Marginal stable response is constant amplitude and frequency of oscillations. Marginal stable response, how it is means constant amplitude and frequency of oscillations. Frequency of oscillation. Stable system means what happened? Bounded response. Finally, it reaches to the what? 0. Finally, it reaches to the some final value. It reached to the final value. It settled down. It settled down, not for some final value. But here what happened? Constant settle down, not where generally it is at input. Stable system always follows input, not generally it follows at input. So whereas marginal stable system always gives the oscillatory response. It never follows the input, it never goes to infinity. For example, I'll find the response to this. So be remember, non-repeated poles on j omega axis system marginal stable. Marginal stable system response is constant amplitude and frequency of oscillation. Find the response, for example. Find the system response. System response means impulse response. Laplace of impulse is 1. Be remember if you don't know. System response means impulse response. Impulse response. So R of t is del of t, R of s equal to 1. Here R of no, Vi na, Vi of t equal to del of t. Vi of t equal to del of t, Vi of s equal to 1. Now come on. I don't write next time onwards. System response, simply substitute 1. That's all. Input is 1. Laplace of input is 1. Now tell, come on. V naught of S becomes what? 1 by S square plus 1. Apply inverse Laplace transform. What is V naught of t? Simply sin t. Simply sin t. So now draw the response. Draw the response. Zero. V naught of t. Sinusoidal oscillations. Like this. Science of the last. What is the nature tell? Constant amplitude. Amplitude, peak amplitudes, constant peak amplitude. Peak amplitudes are constant, na? Constant peak amplitudes. So constant amplitude and frequency of oscillations. Constant amplitude. Amplitude means peak. It represents the peaks only. Constant amplitude and frequency of oscillation. The system is what? Marginal stable. MS means marginal stable. MS means marginal stable. That means what is the conclusion tell? Whenever poles lies on imaginary axis which are non-repeated, the system response is called constant amplitude and frequency of oscillation. Even there is a names for this. This constant amplitude frequency of oscillations is called even undamped oscillations. Undamped oscillations. Undamped. What is the meaning of damped? Damped means like this, decreasing amplitude oscillation. This is called damping. Is it damping here? Not damping. Not damping called undamped. Undamped oscillations. Undamped oscillations. Oscillations are natural frequency of oscillations. Natural frequency of oscillations. Natural frequency of oscillations are steady state oscillations. Even it is called steady state oscillation. Steady state oscillations. Steady state oscillations. Or even you can call it is a what? Even it is called sustained oscillations. Even it is called sustained oscillations. All are same. Sustained oscillations. All are same. So whenever they say undamped oscillation, natural frequency of oscillation, so sustained oscillation, steady state oscillation, all are same. All are denoted by the name of what? Letter of what? Omega n. All are denoted by the letter of omega n. Omega n, radians per second. What is the omega n? What is omega n here? Therefore, one imaginary part is omega n only here. Imaginary part, because poles are imaginary, na? It is omega n. Natural frequency na omega n. So omega n equal to 1 radian per seconds. Omega n equal to 1 radian per seconds. That's all. So what is the final conclusion? Whenever poles lies on j omega or imaginary axis, whenever poles lies on j omega axis which are not repeated, then system response is constant amplitude and frequency of oscillations. Constant amplitude and which is called undamped oscillations. System response is constant amplitude frequency of oscillations, which is called undamped oscillations. And system marginal stable. And the system is marginal stable. So this is the response of marginal stable system. Stable system, bounded response. Marginal stable system, constant amplitude and frequency of oscillation. Unstable system, unbounded response. Okay. Next problem. Next problem. Repeat the above problem. By considering R equal to 1 ohm, L equal to 1 Henry, C equal to 1 Farad. Come on, do it. Do by yourself. Same RLC circuit only. Just I change the R value. That's all. LC same. Screen not visible. Screen visible or not? Screen visible. Screen visible. Infinity. Shivam. Shivam. Screen visible or not? Only one fellow put it not visible. It is visible. Okay, good. Only one fellow means you check it. The problem with you only. Visible only. Okay, good. Okay, thank you. Right. Tell the answer. So what happened? What is the transfer function? V naught of S by VA of S equal to 1 by LC1 na, so S square plus S plus 1. 1 by S square plus S plus 1. Now find the roots for this. Roots you find S1, S2 minus B plus R minus root of B square minus 4AC by 2A minus B minus 1 plus R minus root of B square means 1 minus 4AC A1 C1 divided by 2A means 2. Find this. Minus 1 minus 3 not a plus R minus J root 3 by 2. That means what are the pole locations? Tell S1, S2 minus 1 by 2 plus R minus J root 3 by 2. Now locate the poles in the S-plane. Locate the poles in the S-plane. Locate the poles in the S-plane. Where are the poles? Real part is minus 1 by 2. Real part minus 1 by 2. Imaginary part is plus J root 3 by 2. Another one minus J root 3 by 2. So like this. What is the exact pole location? This is the pole location. These are called complex conjugate poles. These are called what? Complex conjugate poles. Complex conjugate poles. This is 0. Now tell what is the time constant? What is the time constant? What is the time constant? So time constant is tau equal to minus 1 by 2. Minus 1 by minus 1 by 2 means 2 seconds. Time constant 2 seconds. Imaginary part gives the frequency of oscillations. Imaginary part gives the frequency of oscillations. Frequency of oscillations. Okay. Frequency of oscillations. So that is omega d. That equal to root 3 by 2 radians per seconds. Omega d is root 3 by 2 radians per second. Here damped oscillations have. We don't get natural frequency. Poles on imaginary, natural frequency. Poles in the left, then it is a damped oscillations. Right side is unbounded oscillations. So system is stable. Poles lies in the left hand side means it is a stable system. Poles lies in the left hand side means it is a stable system. Now find the system response. Now find the system response. System response. VA of S equal to 1. VA of S equal to 1. Now tell. Come on. Now V naught of S can be written as what? 1 by S square S plus 1. Can be written as 1 by S plus 1 by 2 minus J root 3 by 2 S plus 1 by 2 plus J root 3 by 2 plus J root 3 by 2. That equal to 1 by, so A minus JB. A plus JB means what? A square plus B square. That means S plus 1 by 2 whole square plus root 3 by 2 whole square. Root 3 by 2 whole square. Then find inverse Laplace transform. Find inverse Laplace transform. Find inverse Laplace transform. Next page. Next. So what you are getting? V naught of S equal to, we got 1 by S plus 1 by 2 whole square plus, okay, wait, root 3 by 2 whole square. Okay. Find inverse Laplace transform. Inverse Laplace transform is V naught of t. What is the inverse Laplace? It is like what? E power minus at sin bt. Laplace of e power minus at sin bt equal to what? B by S plus A whole square plus B square. B by S plus A whole square plus B square. That is a Laplace transform. Same thing. S plus A whole square plus B square. B is not there. Numerator I can product with B and divide with B na. Or if I bring it this side, it will become 1 by B. That means what I'll get? This can be written as actually 2 by root 3 this can be written as 2 by root 3 into root 3 by 2 we can write. Then numerator becomes 1. Then S plus 1 by 2 whole square plus root 3 by 2 whole square. Now this total become what? This total become what? E power minus at sin bt. That means V naught of t can be written as V naught of t can be written as 2 by root 3 into e power minus 1 by 2t sine root 3 by 2 into t. Default you want, you can write u of t. This is the what? Response. Exponential decay. What is this response is called? This is exponential decay. This is oscillation. That means this response is called exponential decay and frequency of oscillations. Frequency of oscillations. This is called exponential decay and frequency of oscillations. Now draw the response. Draw the response. This is t. This is here. This is first I'll draw exponential decay. So draw the exponential decay minus 1 by 2t. This is exponential decay. So what is the time constant? 2 seconds. Time constant is 2 seconds. Reach the steady state by 10 seconds. Product with sinusoidal oscillations. Product with sinusoidal oscillations. What is the resultant? Like this, sinusoidal oscillation. What is the resultant? Your product, for example, you consider here plus 1 minus 1. Just to take it, no problem. So 0 into here some value means 0. That means so 0 into some value 0. Plus 1 into here, for example, just for understanding, I'll take some value. Here 9, here 10, 9, 8, like this and so on, up to 0 I'll consider, just for understanding. 0 into 10, 0. 9 into 1, 9, and it goes to 9. Next, minus 1 into 8, for example, then it come back to what? Minus 8. Next again, 1 into plus 7 means it goes to plus 7. It goes to plus 7. Next, minus 6. Then plus 5. Minus 4. 3, 2, 1, like this. That means what you are getting? Exponential decay, frequency of oscillation. This is called exponential decay and frequency of oscillations. Frequency of oscillations, which are called damped oscillations. Which are called damped oscillation, denoted by omega d. Which are called damped oscillation, denoted by omega d. What is omega d? Omega d equal to root 3 by 2 radians per seconds. System is 100% stable. System is 100% stable. So damped oscillations, the system is 100% stable. System is stable. Okay. System stable. Left hand side poles means system is 100% stable. Okay, na? But if you ask for, if you give RLC circuit, if you ask draw the response, if you ask draw the, or if you give this pole location, for example, if you give this pole location, if you ask draw the response, we cannot do like this inverse Laplace transform, finding, drawing, wasting the time. Match the following questions they'll ask. They'll give like this simply. They don't give location also. Simply they'll give like this. Match with the system response. Match with the system response they'll ask. That means what is the examiner intention? By looking a pole, you should be able to guess the approximate response. For example, this is minus A, this is plus or minus JB, plus JB minus JB. What is the approximate response? Tell V naught of t equal to some constant k I don't want. Exponential, real part is exponential power, e power minus at, real part is exponential power. Imaginary part gives the sign or cos term. Imaginary part always gives the sign or cos. When you will get the cos means in case 0 is there here. In case here 0 is there, then it is cos. If you know 0, then it is sine. No 0, it is sine. Laplace of e power minus at cos bt if you find, then you will get the 0. So no 0 means sine. So sine bt. How to draw the response? Simply how to draw the response means, first draw for always real part. Listen all of you. First always draw for real part. What is the response for real part? I already told. Real part is exponential decay. Imaginary part is oscillations. Real part, left hand side real part, exponential decay, exponential decay. Left hand side real part. First draw the exponential decay. Left hand side real part, draw the exponential decay. So with the time constant of 2 seconds, reach the steady state by 10 seconds. This is the response for real part. This is the real part response. Then fold with respect to 0. Fold with respect to 0. Here impulse means what? Impulse exists only at t equal to 0. Other than t equal to 0, impulse is 0. That's why fold with respect to 0. You fold with respect to 0. If you fold with respect to 0, same envelope will get below 0. Fold with respect to 0, same envelope will get below 0. Same envelope below 0. Then in between make it oscillations. 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 That's all. In between make it oscillation. Simply first draw for real part. Real part is exponential decay. Then fold with respect to 0. Impulse means fold with respect to 0. Step means I'll discuss later. Fold means fold with respect to 0. Same envelope will get below 0. In between make it oscillation. These are called damped oscillations. Damped oscillations denoted by omega d, that equal to √3 raised by 2 radians per second. And the system is stable. Okay. Okay. So we'll take the small break. Okay. Take the 10 minutes break. After 10 minutes again I continue, because then or no break. Without break it is difficult, 3 hours class. So take 10 minutes break. 10 minutes break. After 10 minutes again I'll continue. Okay, now time is 7:40. By 7:80, 7:40 by 7:50 I'll start again. Okay. Take the break. 10 minutes break. Okay. Let's start. So what is the conclusion here? Whenever poles are complex conjugate, whenever poles are complex conjugate, in the left of the S-plane, in the left half of S-plane, in the left half of S-plane, then the system response is exponential decay and frequency of oscillations. Which are called damped oscillations, denoted by omega d, and the system is stable. So total 3 cases are completed. Total 3 cases are completed. Total 3 cases are completed. Okay. Total 3 cases. What are the 3 cases? Negative real axis, exponential decay, pure imaginary oscillations, and real plus imaginary, real plus imaginary, then exponential decay, frequency of oscillations. Okay, na? Next problem. Next problem. Find 1 minute. Find system time constant and system response. Find system time constant and system response to the given pole locations. To the given poles locations. One pole right, right. For example, this is +2, -1, -3, -4, -1. Now tell the answer, anybody. Anybody, what is the system time constant? Anybody answer? What is the system time constant? Two seconds. Is it 2 seconds? Any more answer? 2. Okay, listen. Here, how can you say 2 seconds, man? System time constant. System time constant valid for only stable system. The given system is unstable. Given system unstable. Time constant not defined. Time constant not defined. Time constant is not defined. Time constant not defined. So what is the response here? The response for this pole is, what is the response term for this pole? K1 e power plus 2t plus, what is the response for this pole? K2 e power minus 1t. What is the response for this pole? K3 e power minus 3t. 0 not consists in the response. K4 e power minus 5t. Now draw the response. T0. So T0. What is the response here? This is T. So T0 starts at K1. Exponential rise to infinity. Plus e power plus infinity is infinity, na? Plus T0 start at K2. Exponential decay, reach steady state at 5 seconds. T0 start at K3. Exponential decay. T0 within 1 second reach the steady state here. There 5/3. K4 0. Exponential decay. Now sum of this what? If we draw the response, sum of this is T. This is C of T. It starts at some value of K. 0 plus 0 plus 0 plus infinity become infinity. That means it exponentially rise to infinity. Exponential rise to infinity. Exponential rise to infinity. System is unstable. Exponential rise to infinity. System is unstable. System is unstable. System is unstable. Okay. Okay, that means what is the conclusion? Even one pole in the right. So even one pole in the right, there may be many poles in the left hand side. The system response is exponential rise to infinity. So note. So notice what? If one or many poles lies in the right hand side, many poles lies in the right of S plane, right half of S plane on the real axis, then system response is exponential rise to infinity. Exponential rise to infinity. System unstable. System unstable. Exponential rise to infinity, system unstable. That's all. So if one or many poles lies in the right of S plane, the system becomes the unstable. Okay, na? That right side pole gives the unbounded response. So unstable system does not exist the time constant. Time constant defined for only stable systems. We cannot define time constant for unstable systems. Okay, na? Next one. Next, I'll consider the different poles locations. So you draw the response for that. For example, one pole on the negative real axis, one pole at origin, one pole in the right side. For this, what you do? For example, you take here minus A, you take no problem. This you take plus A. Then first you write transfer function to this. First write the transfer function. Next to find system response. Next to draw the response. Then find the stability. Come on, do it. All of you do it. Do it. Right. Now what is the transfer function? We can take 1 by R, K by also we can take. K also constant, 1 also constant. K by R 1 by S plus A. 1 by S plus A is a transfer function. What is the system response? 1 e power minus AT. Default U of t. Now draw the response. Draw the response. T0, it starts at 1. T infinity, exponential decay. System what? Stable. Is bounded response na? Stable. Bounded response stable. Or the output follows the input here. This is the output. This is the output. Input is 0 here. Impulse means what? Impulse exists only at t equal to 0. Other than t equal to 0, 0. Input is 0 here. Output also moving towards the 0. That means output follows the input. Then we can say system stable. Our simple logic is what? Simple logic is what? E power minus t, up to t tends to infinity. E power minus infinity 0. Bounded stable. Next here, 1 by S transfer function. Response 1 u of t. 1 u of t. Then what happened? Draw the response. It is a step input. It is a step response. 1. Now what is this system? Marginal stable, because impulse input 0. It's not moving towards the input. It is not moving towards the input. Input 0 na here. Input 0 not moving towards the input. If moves towards the 0 or input 0 other than t equal to 0, 0 impulse. So if moves towards the 0, then I can say stable. In case if it goes to infinity, I can say unstable. Neither follows input nor goes to infinity means what? Marginal stable. Neither follows input nor goes to infinity means marginal stable. So non-repeated poles on imaginary axis, marginal stable. Non-repeated poles on j omega axis, the system is marginal stable. Marginal stable. Non-repeated poles on j omega axis system is marginal stable. Next, right side. So what is the transfer function? 1 by s minus a. So what is the inverse Laplace transform? 1 e power plus at, default of t. Now draw the response. This is t. This is t. So 0 starts at 1. E power my at goes to infinity. So exponential rise to infinity. It is goes to infinity, na? System become unstable. Right hand side always unstable. Left hand side always stable. Imaginary axis non-repeated poles on j omega axis stable or bounded or follows the input. Input 0. Impulse means other than t equal to 0, 0. Follows the input stable. Away from input unstable. Neutral response, constant amplitude and frequency of oscillation, marginal stable. Okay. Next, you take the repeated poles. Next, take repeated poles. Two poles repeated at s equal to minus a. Two poles repeated at s equal to 0. Two poles repeated at s equal to plus a. Come on, do it. Do by yourself. Do by yourself. Bolo. What is the transfer function? 1 by s plus a whole square. 1 by s plus a whole square. Two poles na whole square. Inverse Laplace transform t e power minus at. Default of t. Now draw the response. Now draw the response. What is the response? Ramp signal product with exponential decay. Ramp signal product with exponential decay. Exponential decay. What is the resultant waveform here? What is the response? What is the response? For example, see, just for understanding, I'll take here T0, here 0, 1, 2, and so on up to 10. I'll take here 10, 9, 8, up to 0. Now product and draw the response. 0 into 10, 0. starts from 0. 1 into 9, 9. It goes to 9. 2 into 8, 16. 3 into 7, 21. 4 into 6, 24. 5 into 5, 25. Again, what happened here? 6 into 4, 24. 7 into 3, 21. Finally, 10 into 0, 0. That means it increases and then decreases. Increases and decreases. If we draw the response, it will increase like a ramp signal and decrease exponentially. Increase like a ramp signal and decrease like exponential. Decrease like exponential. Increase like ramp signal, decrease like exponential. The system becomes stable. The system is stable. So it is a bounded na t equals c t e power minus at. If it is there, what is the value at t equal to 0 means this will become 0, e power 0 become 1, it will become 0. At t equal to infinity, what is the answer means? Infinity into 0, not defined. But infinity means practically 5 tau. Steady state t equal to infinity theoretical. Practically it is 5 tau. 5 tau into 0 becomes what? 0. That's why at the steady state it becomes 0. Then the response is bounded. The system is stable. Even n poles are repeated here. In case n poles repeated, you will get t power n by n plus 1, t power n plus 1 by n, you will get it. So one pole t means what happened? So n plus 1 poles if repeated, you will get t power n by n factorial, you will get. Laplace of t equal to what? 1 by s square, na? T power n means what here? N plus 1, here n plus 1 factorial. So that means n factorial, I think. N factorial by s power n plus 1. So that means what happened? If many poles are repeated, even t power 10 by 10, for example, e power minus at is there at t equal to 0, 0 only. At t equal to infinity also 0 only. So why? Because the exponential decay term always dominates as compared to t terms. Exponential decay term always dominates as compared to t terms. As compared to t terms. Exponential decay term is dominates as compared to t terms. So that's why at t tends to infinity, we have to observe only exponential decay. At t tends to infinity, we have to observe only exponential decay. For larger values of t, exponential decay term is dominates. For smaller values of t, t term dominates. Okay. So system is stable. 1000 poles repeated also system is stable. Next, imaginary. 1 by s square. Tu of t. Ramp signal. What happened? Tell here. Ramp signal. What happened? It is a ramp. System, what happened? Unstable. Yes or no? Unbounded t equal to infinity means it will become infinity. Unstable. That means repeated poles on imaginary axis unstable. Repeated poles on j omega axis. Repeated poles on j omega axis, system is unstable. Repeated poles means unstable. Non-repeated poles means marginal stable. Non-repeated poles means marginal stable. Next, right hand side. 1 by s minus a whole square. Then what you are getting? T e power plus at. Default of t. T means ramp. T means ramp. So ramp signal product with exponential rise. Ramp signal product with exponential rise. Exponential rise. Then what is the answer you will get? You product these two. You product these two. then what you will get? 0 into some value, 0. It starts from 0. Infinity plus infinity means infinity only, means exponential rise to infinity, still quickly rise to infinity. System is what? Unstable. Right hand side always unstable. Right hand side always unstable. Left hand side always stable. Imaginary. Repeated means unstable. Non-repeated means marginal stable system. Okay? Next. Next, complex poles you take. Complex conjugate poles. Come on, now do it. Find the responses, all of you. Come on, for example, you take this is minus A plus JB minus JB plus JB minus JB plus A plus JB minus JB. Now find the transfer function 1 by. So what is the transfer function here? Tell. 1 by S equal to minus A, na? That means S plus A. S plus A minus JB. S plus A minus JB into S plus A plus JB. Yes or no? S plus S equal to minus A means S plus A minus JB plus JB. So like this, our simple logic 1 by S equal to minus here A minus JB into A plus JB, A square plus B square. Directly can write. But how to write directly means S equal to minus A means S plus A. How many poles are there? 2 poles at minus A. One positive imaginary, one negative imaginary. 2 poles. So put it square. Plus product the imaginary. Plus JB into minus JB is called B square. Plus JB into minus JB is equal to B square. Or simply write like this. S plus A minus JB, S plus A plus JB. So A square plus B square. S plus A whole square plus B square. Inverse Laplace transform. 1 by B. This is A, na? This is B. So S square plus B square. S plus A whole square plus B square. Now 1 by B. What is inverse Laplace transform? E power minus AT sine of BT. E power minus AT sine of BT. U of T. U of T. Now draw the response. How to draw the response? First to draw for real part. First to draw for real part. First to draw for real part. So what is the real part of response? Exponential decay. Real part is exponential decay. Fold with respect to 0. Same envelope will get below 0. In between, make it what? Oscillations. In between, make it oscillations. In between, make it oscillations. These are called damped oscillations. System is stable. System is stable. Damped oscillations, omega d. System is stable. Omega d. System is stable. Similarly, second one you do 1 by S equal to JB means what? S minus JB into S plus JB. Then what will get? 1 by S square plus B square. 1 by B sin BT. 1 by B sin BT. So now draw the response. Now draw the response. So what I will get? Sinusoidal oscillations. System is what? Marginal stable. Non-repeated poles on imaginary axis. Non-repeated poles on j omega axis. J omega axis. The system is marginal stable. Similarly, right hand side. 1 by, now write directly. S equal to A means what? S minus A. At that real part, 2 poles. 1, 2. 2 poles, so square. Plus JB into minus JB, B square. Plus JB into minus JB, B square. Now apply inverse Laplace transform. 1 by B e power plus AT sin of BT. Sin of BT. Default U of T. Default U of T. Now draw the response. Now draw the response. First draw for real part. What is the real part of the response? Exponential rise to infinity like this. Exponential rise to infinity. Fold with respect to 0. Because of the impulse, fold with respect to 0. Same envelope will get below 0. Fold, I already told. First draw for real part, then fold with respect to 0 for impulse. In between, make it oscillations. In between, make it oscillations like this. In between, make it oscillations. The system is what? Unstable. The system is unstable. The system unstable. Right side always unstable. Left side always stable. Imaginary non-repeated marginal stable. Repeated poles unstable. Okay. So finally, don't take repeated complex poles because you will get summation terms. Summation terms you will get. So that they don't ask in the exam. That's why no need to take repeated complex. Summation means this plus one more term you will get. That way. Now finally, what is the conclusion means? Get the screenshot. Finally, what is the conclusion means? If transfer function R S plane, if transfer function R S plane, here system response. System response. If transfer function R S plane consists only real poles, then the system response is consists the exponential terms. The system response is consists the exponential terms. System response consists the exponential terms. If a transfer function R S plane consists imaginary poles, even one more thing, if you see the exponential term, then you should say the poles are real. If you see the exponential term, based on exponential power, you should say what is the location of real pole. If you see imaginary term, imaginary pole, the system response consists sine or cos term. sine or cos term. When you will get the cos means there should be 0. For example, Laplace of sine bt. What is the Laplace of sine bt? B by s square plus b square. That means what is the pole location? Plus jb minus jb. That means the b is a what? Imaginary part of the pole. In case Laplace of cos bt means what happened? Same thing, but s by s square plus b square means here 0 is there, then cos. Otherwise it is sine. Next, if 0 is there, then it is cos. If you know 0, then it is what? Sine. So for here 0 should be there, s equal to 0. Here poles plus jb, pole location same, either sine or cos. Next, real plus imaginary pole, complex poles. Real plus imaginary poles. Real plus imaginary pole, complex conjugate. Real plus imaginary poles, complex poles. Then what we will get? Product of exponential and sine or cos terms. Sine or cos terms. Product of exponential, sine or cos terms. Next, repeated real poles. Repeated real poles. Repeated real poles means product of t repeated real. Repeated when you will get t term is there, repeated you will get t term. So if t power 10 is there means 11 poles are repeated. So that means t term represents the repeated poles. So repeated is there means t term present. Product of t and exponential terms. And exponential. Product of t and exponential terms. So be remember this. You be remember this. If you see the system response, you should identify the poles. Exponential powers are real part. Sine or cos terms are imaginary part. In case complex conjugate poles is there, then exponential sine or cos terms will get. If the repeated poles are there, left hand side repeated poles or right hand side repeated pole, t and exponential terms will get. Left means exponential decay will get. Right means exponential rise will get. Okay. Next problem. Find the transfer function. But I'll start with the next page. Find the transfer function. Find the transfer function. Come on. 1 mega, 1 micro, 1 mega, 1 micro. Microfarad. 1 microfarad, 1 microfarad, 1 mega ohm. Here 1 mega ohm. Find the transfer function. Come on. Do it. Tell the answer. Anybody answer? Completed? Right. Solve it. What is the answer? Anybody? Okay. So first, Laplace of resistor is resistor only, VI of S, V naught of S. Capacitor is 1 by SC, 1 by SC. C is 1 micro. Here also Laplace of capacitor 1 by SC, C is 1 micro. C is 1 micro. Now, find the transfer function. First, simplify series parallel blocks. First, simplify the series blocks. Then simplify these parallel blocks. Then we'll get the transfer function. First, simplify the series blocks. What I will get here? 1 mega plus 1 by SC. C is 1 micro. That means what you are getting? Cross LCM if you take, yes, 1 mega and micro becomes 1. S plus 1 by S into 1 micro. Now these two is simplify. This two is simplify. Parallel combination. Parallel means series means added, na? Parallel means product by summation. 1 mega into 1 by SC divided by 1 mega plus 1 by SC. Now simplify this. 1 mega by S plus 1. 1 mega by S plus 1. S plus 1. Now find the transfer function. Now find the transfer function. What is the transfer function? Tell. V naught of S by VI of S equal to impedance across output means 1 mega by S plus 1 divided by total circuit impedance S plus 1 by S into 1 micro plus 1 mega by S plus 1. 1 mega by S plus 1. S plus 1. Then what is the answer? Tell. The answer is LCM you take. You take LCM. Then you will get the answer. LCM denominator what happened? S1 micro, S plus 1. S plus 1 cancel. S1 micro goes to numerator. It becomes 1 micro and mega becomes 1. So S by here simplification you should do S plus 1 whole square plus S micro mega becomes 1. That means what is the answer? S by S square plus 2S plus 1 means 3S plus 1. This is the answer. This is the transfer function. So like this, you have to get the transfer function to this problem. Next problem. I hope completed. Next problem. Completed na this one? Got the answer na? Next problem. Find the transfer function. Find the transfer function. Come on, do it. Right. 1 ohm, 1 farad, 1 ohm, 1 Henry, 1 ohm, 4 farad. Find the transfer function. Come on, do it. Completed? Answer? Answer, anybody? Okay, I'll solve it. First, this is Laplace of capacitor 1 by SC. C is 1. Laplace of inductor SL. L is 1. Laplace of capacitor 1 by SC. C is 4. Now simplify this series combination. This series combination. And then parallel. This series combination means 1 plus SL. 1 plus S. This series combination is 1 plus 1 by S. But these two of it is, these two, both are parallel. These two are parallel. So parallel means product by summation. That means 1 plus S into 1 plus 1 by S divided by 1 plus S plus 1 plus 1 by S. 1 plus S plus 1 plus 1 by S. Now expand this. Numerator expand this. If you expand the numerator, what I will get? 1 into 1, 1. 1 into 1 by S, 1 by S. S into 1, yes. S into 1 by S, 1. Denominator also same, na? 1 plus S plus 1 plus 1 by S. Both are same, numerator, denominator. Cancelled. It will become 1. And this total becomes the 1. This total becomes the 1. Now find this series combination. The series combination is below 1 plus 1 by SC. C means 4. 1 plus 1 by S for S4. Now find the transfer function. What is the transfer function? V0 of S by VI of S equal to impedance across output 1 plus 1 by SC divided by total circuit impedance 1 plus 1 plus 1 by SC. 1 plus. So what is the answer? S power 4, sorry, 4S or S4, whatever it is, 4S plus 1 by 4S, 4S. So 8S plus 1. So here order is first order. Actually third order we should get because 3 storage elements. But what happened? The series parallel combination get the cancel. RL is just like leading. RC is lagging. For example, this is plus 45 degrees. This is like a minus 45. Net angle cancelled. Into what happened? It is act as a just like resistive. So that's why we got it react here, resistive value, like 1. So real value we got it. So because of the cancellation, the order is changed. Otherwise, we might have got the what? Third order system. Okay. Next, one more problem. Simple problem, solve it all of you. Very simple problem. This is asked in the GATE exam. Find a transfer function. Come on, already we solved it with the numerical asked. That's all. There is no difference. $100 microfarad, 10 millihenry, 10 kilo ohms. Come on, tell the answer. Find the transfer function, all of you. Come on. What is the answer? Right. Okay, good. Listen. So transfer function is Laplace of inductor SL, S into 10 milli. Capacitor 1 by SC, C is 100 micro. Now find the transfer function. V0 of S by VA of S equal to impedance across output 1 by SC, C is 100 micro, divided by 10 kilo plus SL, L is 10 milli plus 1 by SC, C is 100 micro. C is 100 micro. Now simplify this. If you simplify this, then what we will get? This cancelled. That means numerator 1. 1 by S into S, S square. Second term if I take S square. 10 into 100 kilo. Kilo milli cancelled. Here milli na. That means here it should be micro. Plus S into 10. 10 into 100 kilo. Kilo mega. Mega micro cancelled. That means plus 1. So micro means 10 power minus 6. That means what I can write? 1 by 10 power minus 6 S square plus S plus 1. 10 power minus 6, if it goes take to the numerator, what happen? Divided by 10 power 6 you can write, na? LCM you take, here 10 power 6, here 10 power 6, here 10 power 6. That means what is the answer? 10 power 6 by S square plus 10 power 6 S plus 10 power 6. This is the answer. Okay. Next, one more. I'll take, till now we taken Z1, Z2 only. In the GATE exam, till now they asked only Z1, Z2 combination only. In case Z1, Z2, Z3, Z4 is there, how to solve? Find the transfer function. Find transfer function. Here Z1 of S, Z3 of S, Z2 of S, Z4 of S, V0 of S, VA of S. So if the network gives this way, Z1, Z2, Z3, Z4, then how can you get the transfer function? How can you get the transfer function? One way is we can solve by using Thevenin's theorem also, network theory, by sorting the input of finding Z3, H and V Thevenins, then we can find the transfer function. The second way will go by standard procedure. Standard procedure will go. Standard procedure, one more thing, never divide the network into parts. Some students, they'll take here V0, 1 of S, then they'll write V0 by VA equal to V0 by V01 into V01 by VA, they'll write. But this is wrong. It is not correct. It is wrong. Why? Because then what you will write? V0 by V01 means you will write Z4 by Z3 plus Z4 you will write. Then here what you will write? Z2 by Z1 plus Z2. It is wrong. Why? Because this is not Z2. Next stage impedance falls on the before stages. That is called loading effect. That is called loading effect. Next stage, for example, here 1 kilo ohm resistor is there, which is connected parallel with 100K. For example, here you take 100K, for example. 100K kilo ohms resistance is there here parallel with, for example, 1K. Then what happened? The next stage impedance falls on the before stage. Then if you observe here resistance, it is not 100K. Below 1K you will get parallel combination. That means what? This is called loading effect. Next stage impedance falls on the before stages. Next stage impedance falls on the before stages. That's why never divide the network into parts. Never divide the network into parts. If you divide it, then you will lose the marks. Okay? Never divide the network into parts. Okay? Right. One minute. Right. Next, listen. Fine. We'll go by standard procedure. Never divide the network into parts because loading effect will be there. If you want to divide, you can divide if the stages are isolated like this. If you want to divide, you can divide. For example, here, connected infinite resistance. Infinite means what? Two stages are isolated. There is no link. Open circuit. Then we can divide. We can divide the networks just to product, find this transfer function, find this transfer function, both product it with this gain, then you will get the answer. If it is open circuit, infinite resistance is there, then we can divide. Otherwise, you should not divide the network into parts because there exists the loading effect. Loading effect means next stage impedance falls on the before stage. It will come in the network theory. Or even unlock circuits, it will come. Loading effect. Now, find the, here, apply the KVL. So this is, I'll take here current is I1 of S here. Here current is I2 of S. Write the KVL equations. Here KVL 1. Here KVL 2. Then you simplify the equations. Then you will get the, actually, I can write the direct answer, we can remember. But some students, they are asking, sir, we want derivation. So that's why I'm solving. And most of the students just not even studied control system. That is the problem. So now I'll solve this. So apply KVL 1. KVL 1. So VI of S equal to, what is VI of S? Apply KVL. I1 of S into below Z1 of S plus Z2 of S. Then this current move in opposite direction, minus I2 of S into Z2 of S. This is equation number 1. Minus I2 of S into Z2 of S. Next KVL 2. KVL 2. So what is KVL 2? 0 equal to, here no external voltage, na 0. 0 equal to. So this is the main loop. This current opposite direction, na? This is the main loop. This opposite. That means minus I1 of S, Z2 of S plus I2 of S into Z2 of S plus Z3 of S plus Z4 of S. Z4 of S. This is equation number 2. This is equation number 2. Then this is equation number. Next, V0 of S. What is V0 of S? Tell. I2 of S into I2 of, this is V0. I2 of S into Z4 of S. This is equation number 3. Then if you solve these 3 equations, then you will get the transfer function. Actually, what do you want? V0 by Vi you want. But V0 not linked with Vi. V0 linked with I2. That means this I2 should be eliminated in terms of Vi. I2 should be eliminated. I2 should be eliminated. I2 should be eliminated. Eliminate in terms of Vi. Eliminate in terms of Vi. In terms of Vi. For this, what you do? You put these equations in matrix form. How can you eliminate? We have to get the I2 first. Then you substitute here. Then you will get the answer. How to get I2? So equation 1 and 2 put in a matrix form. Equation 1 and 2 put in a matrix form. Come on, write the matrix form. Equation 1 and 2. So adjust into matrix form. Vi of S. Put in a matrix form. Vi of S 0 equal to, here what? Z1 plus Z2. Here minus Z2. Here I1 coefficient. Z1 plus Z2 na, I2 coefficient minus Z2. Here I1 coefficient minus Z2. Here I2 coefficient Z2 plus Z3 plus Z4 into below I1, I2. I1 of S, I2 of S. Put into matrix form. So if we expand this, what I will get? I1 Vi of S equal to Z1 plus Z2 into I1 minus Z2 I2. Same thing like this. Now get the I2 of S by using Cramer's rule. By using Cramer's rule. Okay. So now I'll write in the next page. By using Cramer's rule. By using Cramer's rule. Cramer's rule. So what do you want? I2 of S you want. I2 of S equal to, what is the numerator means? Denominator is simply det of the matrix. Denominator is simply det of this matrix. Det of this matrix. That means what is the det? Det means here Z1 plus Z2. Here minus Z2. Here minus Z2. Here Z2 plus Z3 plus Z4. Det of the matrix. Numerator you want. What is the numerator? What do you here want? I2. What are the I2 elements? Tell. These are I2 elements. This is what I1 elements. These are I1 elements. Dekho. Z1 plus Z2 minus Z2 I1 elements. These are I2 elements. This is I1 elements. These are what? I2 elements. These are I2 elements. We want I2 means I2 elements replaced by Vi. I2 elements should be replaced by Vi. I2 elements should be replaced by Vi. That means what I should write? I1 element should be same. I1 should not replace. I1 should not change. Only I2 should be changed. That means here what happened? Z1 plus Z2 minus Z2 same. Minus Z2 is same. Minus Z2 is same. Then what you have to do here? This I2 elements replaced by source. That means what I should write here? Vi of S 0. Then simplify, you will get the answer. Now find the det. Numerator 0. 0 minus of minus means plus Z2 into Vi of S divided by Z1 plus Z2 into Z2 plus Z3 plus Z4 minus Z2 square minus Z2 square. Then I2 of S equal to bolo Z2 into Vi of S. Denominator expand it. Expand karo. So what I will get? Z1 into remain 3 na. Z1 into Z2 plus Z3 plus Z4. Next plus Z2 into remain 3. Z2 into Z2 means Z2 square minus Z2 square cancel. That means what I will get? Z2 into Z3 plus Z4. So this is equation number 4. 4 in 3 you will get the answer. 4 in 3. 4 in 3. You substitute in 3. So you substitute here equation 3 is in place of I2 of S is substitute. Then you will get this I2 of S is substitute there. V0 of S equal to Z2 into Z4 into Vi of S divided by Z1 into Z2 plus Z3 plus Z4 plus Z2 into Z3 plus Z4. Finally, what is the transfer function? V0 of S by Vi of S equal to Z2 Z4 by Z1 Z2 expand it plus Z1 Z3 plus Z1 Z4 plus Z2 Z3 plus Z2 Z4. This is the final transfer function. So be remember this, so that directly we can substitute Z1, Z2, Z3, Z4 values. Directly we can write the transfer function. So be remember this expression Z2, Z4 by Z1, Z2 plus Z1, Z3 plus Z1, Z4 plus Z2, Z3, Z2, Z4. If you ask for 1 mark, you cannot solve like this. Simply we'll substitute the values, we'll write the answer. Simply how to remember means simple logic. Listen. How to write the answer means simply V0 by Vi equal to product of shunt impedances. These two. Product of shunt impedances. These two. Product of shunt. That means Z2, Z4 by Z2, Z4 by take first element. Product remain 3. Z1, Z2. Z1, Z2 plus Z1, Z2 plus Z1, Z3. Z1, Z3. Z1, Z2 plus Z1, Z3 plus Z1, Z4. Z1, Z4 plus first element completed. Next, check the second element. Z2, Z3. Z2, Z3 plus Z2, Z4. Z2, Z3, Z2, Z4. Z2, Z4. That's all. Don't product last two components. Don't product Z3 into Z4. Denominator total 5 terms. 1, 2, 3, 4, 5. 5 terms. Okay, be remember this. Tomorrow we'll solve the problems. So by using this network, we'll take 4 components like Z1, Z2, Z3, Z4 and we'll solve the problems tomorrow. Okay. So now if you have any doubts, you can ask. You can write the hand. We'll close here. Tomorrow we'll discuss the continuous. We'll solve the problems. Okay. Akansha.
Hello.
Tell.
Sir, if the left hand side number of poles is more than 2, then also it will be stable.
1000 infinite number also stable only.
Okay.
Because exponential decay term is their left hand side means e power minus t term will be there. That makes the system stable.
Okay, okay, sir.
Next.
Thank you, sir.
Next. Natsha.
Hello, sir.
Tell.
So why do we use default signal as u of t?
U of t represents signal is positive side, t greater than 0. That's all.
But
Okay,
in
we
some
don't draw
cases we
response
don't,
for negative values of t.
Okay, sir.
Okay. Next, Naga. Naga Nitesh.
Good evening, sir.
Good evening, Telma.
Sir, you said for exact response we should consider poles. You said no, sir.
Poles and zeros. Exact means poles and zeros.
Aye, sir. Zeros. If there is any change in the zeros, then will it affect the system
Constant term
response?
will change. K I written na? K1, K2. That constant term will change. That's all. Exponential terms are not changes. Only constant term will change.
Okay.
Okay.
Yes, sir. Means if s plus 2, for example, s plus 2 is there, sir. For exact response, we consider that pole.
You have to consider, na?
Yeah, yes, sir. If I mean, like again, s minus 2 we didn't, sir.
Yes. Where it is? Numerator or denominator?
Numerator,
Whatever.
sir. Numerator, sir. Denominator is same, but
Whatever it is, s plus 2 or s minus 2, na, that won't be matter. Here I'll write k by denominator term. Na. Whatever
okay,
the numerator, that will be there in the k.
Yes, sir. Got it, sir. Got it, sir.
That means changes only in the k.
Yes,
Denominator term, no change, na?
Yes, sir. Yes, sir. Got it. Thank you, sir.
Okay. Next, Abdul.
నాది అది ఒక డౌట్ ఉంది సార్, అది కన్ఫ్యూజన్ ఉంది. సి ఆఫ్ ఎస్ బై ఆర్ ఆఫ్ ఎస్ అది మనం అది డిఫాల్ట్ కండిషన్ సార్, అవుట్పుట్ బై ఇన్పుట్ తీసుకుంటాం.
Yes, anywhere output by input only. Na? Transfer function means output by input.
ఇంకోటి మనం ఆర్ ఆఫ్ ఎస్ ఇంపల్స్ రెస్పాన్స్ తీసుకుంటాం, సిస్టమ్ రెస్పాన్స్
System response అంటే ఇన్పుట్ ఇంపల్స్. దట్స్ ఆల్.
ఇన్పుట్. ఇంకోటి సార్, ఇప్పుడు జీరోస్ అంటే ఎలా తీసుకుంటాం అర్థం కాలేదు. పోల్స్ అర్థమైంది. పోల్స్ అంటే మనం ఎస్ ప్లస్ 2 మైనస్ 2 అలా తీసుకుంటాం. జీరోస్ అంటే అర్థం కాలేదు ఇందాక.
జీరోస్ అంటే ఏంది? జీరోస్ అంటే ఏం అర్థం కాలేదు? వాడు ఇస్తాడు, మనం తీసుకునేది ఏం లేదు.
జీరోస్ అంటే రియల్ వాల్యూ లేకపోతే ఇమాజినరీ వాల్యూ?
It may be real, it may be imaginary. If I write, for example, s plus 2, this 0 is real. If I write s square plus 2, this 0 is imaginary, plus or minus j root. Depends on the term, na?
Okay. అనే టర్మ్ బట్టి మనం పోల్స్ జీరోస్
రిప్రజెంట్ చేస్తాం అంతే. రూట్స్ కనుక్కోవడం, రిప్రజెంట్ చేయడం.
ఓకే సార్.
నెక్స్ట్, సుస్మిత.
Good evening, sir.
గుడ్ ఈవినింగ్, చెప్పమ్మా.
Sir, how can a high gain can result in instability problem, sir? గెయిన్ అసలు గెయిన్ మనం ఇంక్రీజ్ చేస్తే స్టెబిలిటీ దానికి ఎలా
తగ్గుతుంది.
అవుతుంది సార్?
That will come in the root locus.
ఓకే ఓకే సార్.
ఓకేనా?
యాక్చువల్ గా ఐఏఎస్ లో ఒక బిట్ ఇచ్చారు సార్. సేమ్
అవునవును. రూట్స్
బేసిక్స్
ఏమైతే అంటే రైట్ కి షిఫ్ట్ అవుతాయి. as k increases generally roots moves to the right. It will come in the root locus. Okay.
ఓకే ఓకే సార్.
చంద్రబాబు
Hello,
చెప్పమ్మా.
am I audible, sir?
Audible, tell.
If the poles are right side, then it will be unstable, sir, system.
Yes, unstable because unbounded response.
If you get the bounded output at right side of the pole.
Right side bounded output you never get it because e power plus t term is there.
Okay.
Okay
Sir,
na?
you write that sir, e from minus 8 u of t. You write the exponential term right side, sir.
Right side? Right side e power plus will be there.
Okay.
E power plus and unstable.
Okay, sir.
Okay.
Clarify.
Next, Sai Kumar.
Sir, good evening.
Good evening, Chapama.
Sir, in this question, sir, sir, here total resistance we can do like this, no, sir. Z4 plus Z3 whole parallel to Z2.
We can find Z Thevenins. We can find what is there.
Sir, but if we like do that, it is
Thevenins there. We have to Z4 should be load. It should be open. Input should be short circuited.
yes, sir. Yes, sir.
Like that is all you will get the answer.
Yes, sir. Yes, sir. That's all, sir. Thank you, sir.
Okay. No more doubts, na? I'll close it.